Alright guys, so let's start. That is chapter 7, okay? In chapter 7 we're going to start with example 1, and these examples are going to make you pretty good, okay? You will learn quite a bit. Now the book I'm using is, as you guys know, we are using Electrical Machine Drive and Power System, and that is by the Theodore Weldy, the best book there is. And the another book is the Chapman, which is a very good book if you want to become an electrical engineer. So right here, if you guys see, we are continuing our discussion on three-phase systems. So a sinusoidal voltage have a peak value of 162. So anytime it says a peak value, that is the max value. So if we come right here, so what he's saying is it is this guy right here, right? And it says it is a sinusoidal voltage. So this peak value is 162. So when you see this, automatically you would do like this: em sine of theta. Okay, so this value right here is what? It is 162. Okay, we got a frequency, it's in the US, so it is 60 hertz. If it was British or mostly the rest of the world, then it would be 50 hertz. Okay, the resulting current has a peak value, and the current has a peak value of how much? It is 7.5, and lags. So lagging, let's say it's right here. So this is lagging, this is the current. Okay, so he comes first, then he comes second. So this is right here is 50 degrees, and the peak value is how much? The peak value is 7.5. Okay, so he is lagging. So to write the current equation, always you do like this. So you say I equal to Im sine, okay, pi, and it is he is lagging, so minus 50 degrees. Okay, and if he was not lagging, so this minus 50 would not be there. Okay, so what it says is behind the voltage. Express the voltage and current in terms of electrical angle. So that's what it is right here. This is electrical angle, and this right here. So we represented them in electrical angles. Calculate the value of instantaneous voltage and current at an angle of 120 degrees. That's very easy because we already got formulas. So if we want to, instantaneous mean at that instant when the angle is 120 degrees. So if you already have this formula, that's easy. E equal to the voltage. Em, what is the Em? That is the peak value, that is 162, 162, and we're going to say sine up at 120 degrees. So that should be 140.3 volts. Okay, as this angle is changing, you will see as this angle is changing. So what is going on? See right here, when we start, the voltage is 0, then it is going up, then it goes to max, and then it goes down, goes to 0 again, go on the negative side, and go again toward the max. That's what it is talking about. So the voltage at this point is going to be 0. It's going to go up, it's going to go up, and then it's going to reach to 162, then it's going to drop down. Okay, so that angle, don't get confused. We can say sine of 0, sine of, sine of 20, 30, 40, 50, and we can look at all of them and recreate and create this whole wave. All right, if you want to look at the current, so that is our voltage. If you want to look at the current, well, the I max is what? The I max is 7.5. So you do 7.5, and sine of, we got 120 degrees minus 50. That's that easy. So you do this, and what you find is it's 7.05. So um, when he's lagging with minus 50 degrees, okay, and the voltage is at 120, then the current wave is, okay, the current wave is 120 minus 50 is 70 degrees. So 70 would be somewhere, this is 90. So 70 would be somewhere here. So at that instant, the current, okay, if we are looking at the current, at that instant, the current is 7.05. All right. And if you want to calculate, the power at this instant, so what we say, the instantaneous power, P equal to what? I times V. Yeah, very easy. So what is your I? Your I is, at this instant, is 7.03. 7.05, sorry, 7.05 times what is at this instant the voltage, and that is 140.3, and the power we will get at that point is 989. Now remember, this is what? This is watts. The reason it is watts, because both the power and voltage are positive at this instant. Okay, when the voltage is at 120 degrees, and so 120 degrees would be right here, somewhere right here, 90, and the current is where it is at 70 degrees right here, and the voltage is right here. So if I draw this is your, we draw it clean. So it says the voltage is right here, and the current, the instant they are talking about, is 70 degrees right here. So if you multiply I and V here, they're both positive, we will get what? Positive power. Okay, or we call it kW. Now I see, if you go down and look at, look right here at a very, very nice table for the young, for the guys who are new to electrical, that would help you a lot. So this you can recreate, and my students, you guys, I have to recreate this wave right here, and I'm going to show you how. So first take the angle 0. So if you take the angle 0, yeah, the formula I show you guys is E equal to the voltage is E max sine pi. And so if you take sine, if you take that, but E max, how much is E max? That is 162. We would say sine of 0, yeah, and that would give you this value right here. If I want to find the current, what we got, current equal to I max sine up. In this case, we got, it's pi minus 0, so this is 0 minus 0, so that would be 0, yeah. And you will come up, sorry, we got minus 50 because it is lagging, the current is lagging, so that would be 0 minus 50.